Hey, so here is part 2 of lesson 2.5, equations of lines. And the first video went over how to find the equation of a line parallel to a given line through a chosen point. Here we're going to find the equation of a line perpendicular to a given line through a chosen point. Remember, once we're done, we should have two lines, okay? The first one is going to be the one that was given, which is y equals 5x plus 4. So the second line is going to have a different slope and probably a different y-intercept, even though the y-intercept could be the same. That's not a big deal here. Our focus is on the slope. All right, so let's start with step 1. Put the equation, as a matter of fact, let's read exactly what we're looking for. We're trying to find a line that is perpendicular to this one that goes through this point. Okay, so let's go through the steps. The first thing is very much like finding the slope, or rather the equation of a line parallel, except for probably one difference. All right, so we're going to put that equation into slope-intercept form. Again, we know slope-intercept form is y equal mx plus b form. Okay, and so I'm going to do that here. Y equals 5x plus 4. I'm essentially just rewriting this. Okay, and so this here is going to be my slope, or m. All right, and now I need to determine, so m is equal to, or the slope of the first line is equal to 5. Second step is determine the perpendicular slope, or the opposite reciprocal slope, because when we're dealing with perpendicular lines, their slopes are inverse reciprocals of each other. So if I have a number 5 here, right, 5 is the same as 5 over 1. So the inverse, or the reciprocal, is, R for reciprocal, is 1 over 5. Okay? So the number 5 is the same as writing 5 over 1, and the reciprocal of 5 over 1 is 1 over 5. So the slope of line 2 is going to be 1 over 5. But wait a second. It also has to be the inverse, right? It has to be the opposite sign. And because the original slope is positive, we've got to make this a negative. All right. So much like what we did before, our next step is to substitute the perpendicular slope and the coordinate points into the equation and solve for b. So we have y is equal to mx plus b, okay, and our coordinates are 10, negative 3. The slope that we're plugging in is negative 1 over 5. And let's go ahead and start the process. Okay, so we're going to plug in all of these values. The only thing that we're going to be finding here is b. Y is negative 3. M, or the slope, is negative 1 over 5 times x, right? That's our x, that's our y, times 10 plus b. Okay, so after I calculate all of this up, I'm going to just rewrite it. 10, and let's multiply that. Don't really need to, but just for the sake of showing you guys how to work with fractions, which I know you hate. Negative 1 divided by 5 times positive 10, yep, times 10 is equal to negative 2. So solve this as a simple equation by adding 2 to both sides. And I'm going to end up with v is equal to negative 1. Okay. So now I have my y-intercept, and I also have my slope. So the equation of my line is going to be, oh, sorry, this is so sloppy, that's a 5. Y is equal to negative 1 over 5, x minus 1. Checking it out on the calculator. to make sure that it is accurate. Just gonna move that down. Sometimes it's really hard to identify whether lines are parallel using the perpendicular using the calculator, because you can't necessarily see the perpendicularity because there's no markings. And so when we graph these, you're not necessarily going to be able to tell. They do look perpendicular to me, but you can check the table. And if the table has these points, 10 and -3, then you should be good to go. 10 and -3. Yep. And so if we're looking at just this one, we're saying that 10 and -3, those points are on this line. And yeah, they are 10, -3. So that is correct. All right. You're going to do the try it out yourself as usual. Any questions, comments, or concerns, please reach out to me. Have a great evening. Bye.